In this chapter, we are going to talk about recursion and recursive function calls in Python. So first of all, you may pose the question that what is recursion? Recursion is a method or procedure where the solution to a problem depends on a solution to smaller instances of the same problem. So we are going to call the same function over and over again in order to reduce the original problem into smaller and smaller instances. So we break the task into smaller subtasks basically. This approach can be applied to many types of problems, and recursion is one of the central ideas of computer science. We are going to talk about backtracking. Backtracking related algorithms rely heavily on recursive function calls. Then, for example, graph algorithms such as breadth first search and depth first search uses recursion under the hood. Or for example, when we want to find the maximum or the minimum item in a binary search tree, we have to use recursion again. By the way, it is not necessary to use recursion because we can solve problems with recursion or with iteration. So we can transform recursion into iteration and vice versa. Recursive approaches are very elegant, and this is why it is a fundamental concept in computer science. By the way, we have to define base cases in order to avoid infinite loops, but we are going to talk a lot more about base cases. Okay, so let's take a look at a concrete example. If we want to add the first n integers, we can use iteration, a simple for loop basically, or we can use recursion, as you can see, where we call the same function over and over again. So let's take a look at the iterative approach. We have integer n, we define a result and initialize it to be 0. We just have to make a simple for loop and make as many iterations as the value of this n variable, and basically we just have to sum up the values. So this is why we increment the result by I. This is how we sum up the first n integers, and finally we return with the result. So this is how we solve this problem with the help of iteration. Let's take a look at the recursive solution. We have the recursive sum function with the input n. We have to define a base case. This is what we have been talking about, that we have to define base cases in order to avoid infinite loops. Of course, if we call the same function over and over again without the base case where we define when to stop the algorithm, of course it's going to be an infinite loop. So if the n is equals to 1, we return 1, and anyways we return with n plus the recursive sum on n minus 1. This is what we have been talking about, that the solution to a problem depends on solutions to smaller instances of the same problem. As you can see, we keep calling the same function with n minus 1 value. What does it mean? That the value of n keeps decreasing, which means that finally n will be equal to 1, and this is the base case when we return 1. Okay, so this is the recursive approach, this is the iterative approach. Both of them are valid and working fine. Let's talk about the types of recursion. There are two types, the tail recursion and head recursion. If the recursive call occurs at the end of the function, then it is called tail recursion. So tail recursion is very similar to a loop, whether it is a for loop or a while loop. This method executes all the statements before jumping into the next recursive call. On the other hand, as far as head recursion is concerned, the recursive call occurs at the beginning of the function. In this case, it is called head recursion. The method saves the state before jumping into the next recursive call, which means that head recursion needs more memory because we have to store the states of the actual function calls. Okay, so let's take a look at tail recursion and head recursion. As you can see, because both of these cases are recursive function calls, this is why we have to define the base cases. So if n is equals to 1, then we return. And as far as tail recursion is is concerned, first we do the operation. In this case, we just print out the value of n, and the last statement of the function is the recursive function call. So this is tail recursion, where no need to consider the last item to be able to get the result for the first operation. This is what we have been talking about, that the recursive call occurs at the end of the function. What about head recursion? As far as head recursion is concerned, again we have to define the base case, then we call this function recursively, and finally we do a given operation. As you can see, the exact opposite what we have done with tail recursion. So first we call this method recursively, and then we print out the value of n, and this is why we have to consider the last item to be able to get the result for the first operation. We are going to talk a lot about the memory complexity of head recursion and tail recursion, and we are going to see that as far as head recursion is concerned, we have to store more items on the stack memory than with tail recursion. Anyways, in the next lecture we are going to talk about the concrete implementation of tail recursion and head recursion. Thanks for watching.